Right. Welcome to the last day of SQL Bits. I hope everyone has had a great conference. Yes? Excellent. Awesome. Well, I've had a great time too. This is my last session, so thank you so much for honoring me with your presence and staying late, because I know everyone's probably starting to get tired. I know I am. Today we're going to talk about SQL Server on Azure Virtual Machine, configuring for price and performance. This is a session I normally do in 1 hour to 1 hour and 15 minutes. So I'm going to go a little bit fast, and I'll do my best to, again, I did trim down the slides a little bit, but I didn't want to tamp down the message because it's an important one. So we'll try to go a little bit fast, but if you do have questions, please feel free to ask me. I'd rather get to your questions and cut a few slides short, okay? So don't be afraid to ask questions if you have them. So my name is Pam Lahoud. I'm the lead program manager for the SQL Server on Azure Virtual Machine team at Microsoft. And I'm SQL Goddess on Twitter. So if I don't get to your questions today, please feel free to tweet at me, and I will get back to you. Probably not until I land back home in Seattle, but as soon as I can. Okay. So how many of you are actually running virtual machines in Azure today? Okay, a good number of you. And you're running SQL Server specifically on those VMs? How many of you have had performance issues on those VMs? One? Really? Only one of you? Wow, I guess we're doing our job. So what many people find when they move their SQL Server to Azure VM is that you have to think about performance a little bit differently than you do on premises. And the reason for that is the way that you provision the services that that virtual machine connects to. Things like storage, what size VM should you pick, one of the 375 different options there are out there. And most importantly, how do you size based on the workload that you're running? And the other thing is, it's a little bit different way of thinking about capacity planning as well. Because when you're on-prem, 9 times out of 10, you're oversizing. You're buying a lot more hardware than you actually need for your workload because you're thinking out, 3 to 5 years. You're thinking about hardware buying cycles. I think it's gotten a little bit better over the past few years because there's so many things running in virtual environments now. So if you're running in VMs on-prem, you might be able to mitigate that a little bit. But particularly in Azure, you have to think about it as you're now like renting hardware. You're paying for it by the minute. And so you want to make sure that you have enough room to sustain your workload today, but you don't want to do as much planning in advance. It's that switch from CapEx to OpEx spending. We're thinking about it differently. And so what I wanted to talk to you about today are some of the really important things that you should be thinking about when you're thinking about migrating your SQL Server workloads from on-prem into Azure. And even once you get into Azure, could you maybe tweak your VM size a little bit to get a little bit more bang for your buck? Okay, so we'll talk about that today. And my doohickey's now, there we go. Okay, so let's start with the different VM options in Azure. And if you were at my talk yesterday, these slides will look familiar. It's a little bit of the same talk, at least up front, in that there are many different compute options for you in Azure. There are, as I mentioned, there's over 300. There were like 385 different VM sizes the last time I looked. There's probably more now. And so there's a vast array of VMs to choose from, and it might be difficult to kind of zero in on what you need, because a lot of them will have the same core count, maybe even the same amount of memory, the same amount of IOPS. Like, how do you choose which one, right? So for SQL Server, for the most part, we're going to stick with either the memory optimized for most of your production workloads, or the general purpose series for your dev and test workloads, and for small production workloads. So these are the ones that you should focus on. So these would be, the memory optimized would be the E and the M series, and then the general purpose would be the D series. And I'm going to dig a little bit deeper into what all these numbers and letters mean when you're choosing a virtual machine size. So, oh, and the sprinkles, we have to do the sprinkles, right? EDS v5, if you want to go home early, I'll tell you this. EDS v5 for most of your SQL workloads, when it comes out in a few months, EBDS v5 will be the best price performance for SQL Server. So if you're tired and you want to go home, that's all you need to hear. Double sprinkles VM, EBDSV5, and then have a good flight home. But if you want to know why I'm telling you that, then stick around for the rest. Okay, so let's start with what is this alphabet soup that makes up these naming conventions for VMs. The first is the family. So I told you those E and M, those are our memory optimized series. So M is like the massive memory. Like that's the most memory you can get in Azure is the M series, and it goes up to 416 cores. So those are massive machines. They have a massive price tag. So we also have memory optimized E series, which is a little more affordable. And actually, it's a good ratio for your SQL servers. It's got a 1:8 core to memory ratio. So that's the family, and like I said, D is the general purpose. And then the number that comes immediately after the family, that's the number of vCPUs that are in the VM. So a D8SV5, for example, has 8 vCPUs. Then there can be any number of lowercase letters. So if uppercase letter is the family, lowercase letter means something. A stands for AMD-based processor. If there's no A in the name, it's an Intel-based processor. If there's an A, and it'll be the first letter, they're in alphabetical order. They'll be listed in alphabetical order. So if the first letter's A, it's an AMD processor. D stands for diskful. It means there's a local SSD that's available inside the virtual machine. And it's ephemeral, which means it can go away if the VM fails over. But that's where we like you to store your tempDB. So that's why it's important for SQL. I is an isolated size. It means you'll be the only VM on the host. So if you have maybe security requirements or really strict performance requirements and you don't want to worry about noisy neighbor, then isolated sizes are for you. L is low memory, so you want to avoid those, right? M is memory intense. So when you get into the M series VMs, you might see MM, and that's like memory, right? So those are the bigger memory ones. T is tiny memory, definitely avoid those. And then S means it's premium storage capable. So you can attach a premium disk to it. So diskful, isolated, those are important for SQL Server. S is also important. I should actually add another red box around S, because you really do want to be using premium or ultra SSD for your SQL Server workload. So S is also important. So this is all documented, by the way. So I've got a link on the slide, VM naming conventions. All of this is documented, so you don't have to memorize it here. And if it changes over time, you'll see it here. So if you get a new letter in there you're not sure about, it will show up there. In fact, I just realized I have an updated version of this slide, and I didn't copy it over. There's a new letter, B, because I've been telling you about this double sprinkles VM, which is EBDSV5. Why do I love it? E, memory optimized family. B, bandwidth. It has the highest I/O bandwidth available in Azure. So B is a new letter you're going to see in here soon as EBDSV5 goes to GA. So B, bandwidth. D, diskful. It's got a local disk. S, it supports premium storage. V5, it's the newest generation of VM in Azure. EBDSV5. That's your double sprinkles, okay? All right, one more thing I want to talk about with sizing, and that's constrained cores. So 1:8 memory ratio is good for many SQL Server workloads. It's not enough for some. You may want more memory, but you may not need more cores. When you're paying SQL Server licensing for those cores, they get very expensive, and you certainly don't want to pay for them if you don't need them. So one of the solutions that you can leverage are constrained core VMs. So a constrained core VM, you notice there's two numbers here. There's an M32-16. That means the base VM, the parent VM, has 32 cores, but you're only going to see 16 cores. So inside the VM, there will only be 16 cores. You only need to license 16 cores for SQL Server. But the compute cost will be the same as the 32-core VM. But if you've ever looked at the pricing, you know the SQL Server licensing cost is the vast majority of the price you pay for a SQL VM. So usually it works out in your favor. So constrained cores can help you get a better core-to-memory ratio without going up to an expensive M-series VM, or even in the M-series VMs if you need more memory. And you can also get more I/O throughput as well, but not upping the core count. All right. Questions there before I move on? Okay, no, we're good? All right. So now I want to talk a little bit more about how storage works in an Azure Virtual Machine. So I've got 3 different kinds of storage listed here. I've got uncached managed disk, cached managed disk, and then local and temp disk. So the way virtual machines work in Azure, you have a virtual machine that's sitting on a host machine. When you have one of those disk-full VM series, there is an SSD drive that is attached to the host. That SSD drive is made available to you inside the virtual machine, and it becomes your D drive or your temp drive or your ephemeral drive, some people call it. So the reason it's ephemeral is if the VM migrates to another host, it's gone. Everything that was on that drive, we're not going to copy it over, so you lose it. So it's not good for putting your data files, but it's great for tempdb. Because if your VM or migrate over, you restart SQL, you're good to go, right? So we like that to use tempdb, to put tempdb on there, and I'll tell you why in a second. So there's SSD level provisioning, which is used for that D drive. Okay, that's local. Then if you attach managed disks are like premium SSD or ultra disk. That's what we call managed disks. If you attach managed disks to the VM, that traffic actually goes over the network. So we have VM level network provisioning for that traffic. And then the disk itself, the premium SSD itself, is also capable of some number of IOPS and throughput. So the disk itself has provisioning attached to it. So there's limitations at each one of these levels. Disk level provisioning has an I/O throughput limit. VM level provisioning has an I/O throughput limit. SSD level provisioning has an I/O throughput limit. Each one of these has an I/O throughput limit that you need to pay attention to when you're sizing. Now there's one thing I skipped over, and that's the middle, the cache. So premium SSD has the ability to turn on what we call Azure Blob Cache, or ABC cache it's called. Sometimes it's called managed disk caching, host caching. There's a lot of different names that it carries. Caching is a free service that just comes with the VM. So it's a good thing for you to turn on because you get some like free IOPS. You get some extra IOPS for free by turning on caching. So that's what we're going to talk about. So that cache is made up of the SSD on the host as well as some memory on the host. And so that what the limit of what you can put in the cache has to do with the SSD level provisioning, okay? So we have limits at the SSD or the local storage level, limits at the disk level, and limits at the VM level. Let's dig into what that looks like. This is an example of a documentation page. This one is for the EDS v4 series, which was my favorite VM before the EDS v5 series came out. And so this is an example of documentation. So how do you look at this documentation? Well, you see the last column says max uncached disk throughput, IOPS, and megabytes per second. This is your VM network level provisioning. This is how much I/O throughput the virtual machine itself is capable of. Okay, so even if you attach disks to get higher than that limit, you will never be able to go higher than that limit for your remote storage. So anything going to the managed disks that are attached to the VM, all of that added together has to be less than or equal to this limit. That's how much the VM is capable of. So you can see here, each one of the sizes, the larger the VM is, the more I/O throughput you get. Okay, so that's your VM level limit. We also have the local, the SSD level provisioning. So the local SSD is called max cached and temp storage throughput because it both hosts the cache and the D drive that's inside the VM. You won't see the cache activity. You won't be able to monitor the cache activity from inside the VM because it's all happening on the host. But anything that goes against the D drive is going to come after this SSD level provisioning. So that's your max cached and temp storage throughput. And then the size of the D drive, so that temp disk, that tells you how large the temp drive is. So you want to choose a VM that has a temp drive large enough to house your tempdb at a minimum, and then enough IOPS and throughput to support both your tempdb and what you think you might be using for caching. So that's your SSD level provisioning. So if we tie this together, I've taken that line of the documentation, I've pulled out those numbers, and I've placed them into that chart that we just looked at. So now you can see here that the SSD level provisioning for the E8 DSV4 is capable of 77,000 IOPS and 485 megabytes per second. That's the limit for whatever you put on the D drive plus the cache. Then you've got the cached, so I'm looking at P30s here. This is disk level provisioning. So a P30 is capable of 5,000 IOPS and 200 megabytes per second. Each one of those P30s is capable of that. So if I have two P30s attached, that's what they're capable of, and that's the disk level provisioning. And then for the VM level provisioning, 12,800 IOPS and 192 megabytes per second. That goes out to your managed disks. That's how much the whole VM is capable of. So that's your VM level provisioning there. So that's how you map these numbers in the documentation to what the VM would be generating. And notice that I have that cached P30 and the local temp disk. I have that number spanning those two. Because again, they're both sharing that limit. They're sharing those IOPS, both the cache and the local D drive. Okay. For your transaction log files, we generally recommend that you turn off caching, because only read caching is available for SQL Server, because when we do writes in SQL Server, we can't honor the cache. We have to flush all the way to storage to guarantee durability. So we have like a flush bit set on all of our I/O. So we can't take advantage of the write caching. So we recommend you do read caching on data files only, and then turn off caching for the log drive. So your transaction log would go on a managed disk that has caching set to none, and then your data files should go on a managed disk. P30 is generally our favorite. I'll tell you why in a second. And these should have host caching set to read only. And then your tempdb should go on the D drive. OK, so let's dig more into these storage options. So managed disk has a number of options available to you. So we do have standard hard drives, standard SSDs. These are slow. They don't have a lot of IOPS. Don't use them. I'm just going to gray them out. Can you use them for your dev and test systems? Maybe. But if you're testing performance, no. They just don't perform well for SQL Server workloads. They have high latency and not enough throughput. So for your production workloads, premium SSD is where you want to go. Premium SSD, relatively low latency, good I/O throughput, and you can pool them together. You pool them together using storage spaces inside the VM, and then you can combine them. So one P30 is 500 megabytes per second. You have two of them together, you get 1,000, right? So you can pool them together. Sorry, it's not 500, it's like 250. But you can pool them together. Ultra disk is very low latency storage, and these are customizable. You can customize the IOPS and throughput per disk. So you can pick however much capacity you need, and you can set the IOPS and throughput on the disk. And it's like millisecond latency, right? Sub-millisecond latency. The problem is they're very, very expensive. So unless you really, really need that low latency, you're probably not looking at ultra disk. So for most deployments, premium SSD is the way you want to go. OK. So here's the sizing chart for premium SSD. Here's your disk level provisioning. This is how much the disks themselves are capable of. So we recommend P30. Why? First of all, P30 is the smallest disk that you can get reservations for. So it's nice for pricing. You cannot turn on read caching for a drive that's 4 terabytes or larger. So you actually can't even turn on read caching for these larger drives. So P30 and P40 is mainly what you're looking at. And so you've got 5,000 IOPS and 200 megabytes per second in that P30. That's probably not going to be enough for most people. So you start chaining them together. when you pool together a large number of P30s, generally it's cheaper than buying a large disk that's capable of the same IOPS and throughput. So you will find, in most cases, it's cheaper to string together a bunch of P30s than to go with one P80, even if you don't care about caching. Okay, so the numbers just kind of work out better for pricing. So that's why we recommend start with P30s and go from there. Okay, Ultra Disk. So like I said, very, very low latency, and you can set the IOPS and throughput, but again, very pricey. Okay. All right, any questions so far before we move? We're good? I just realized I forgot to set my little clock, so could you give me a 10-minute reminder too? Sorry, thanks. Okay. Understanding I/O capping. So what happens when you exceed one of these limits? What happens inside the VM? So basically what happens is we cap your I/O. So your VM is not capable of going above these limits. We do have burstable VMs. So many of these VMs have burst capability. So you may be able to burst above these limits for, say, 30 minutes at a time. But if you have sustained I/O that lasts a long time, you're going to get throttled at these limits. Sorry, it's called capping. They like to call it capping, not throttling. So what will happen is things will start to slow down. Your I/O will start to queue up, and your latency might go up because things are getting backed up, waiting to get out. So it's going to look like a general slowdown for the most part. So let's walk through how the capping works. So I've got SQL Server. It's sitting on an IAAS v4, which is capable of 12,800 IOPS and 192 megabytes per second. I've attached 3 P10s to this. So the P10s are capable of 500 IOPS and 100 megabytes per second each. Okay? So let's say SQL Server requests 10,000 IOPS. And let's say that it's evenly spread across all these 3 disks. So it sends, or not evenly spread, so 4,500 to one, 4,500 to the other, and 1,000 to the other. Now, are these drives capable of 1,000 IOPS even? So no, right? I just told you they're only capable of 500 IOPS. So they can't do this much I/O. You can throw that much at them if you want to, but you're only going to get back, the 500 that they're each capable of. So this is going to be really slow. You're going to get 1,500 IOPS out of this thing, and you're not going to have very good performance. Okay, so here's an example of where you'd be capped at the disk level. Okay. So let's say, okay, we figured out that was a problem. So we upgraded our drives from P10s to P30s. P30s are capable of 5,000 IOPS and 200 megabytes per second. Okay, so let's take that same scenario. 10,000 IOPS coming from SQL Server, spread out across the drives. They're all capable of this much I/O. So at the disk level, this is all fine. You get back all of that. You get back all of that IOPS. However, the virtual machine. Actually, sorry, the virtual machine is capable of 12,800. So no capping would happen here. This VM would be performing fine. Or if it's not performing fine, it's not because of I/O, right? So this VM is working fine. All right, so let's say the application ramps up and SQL Server starts throwing more IOPS at this thing. Okay, so 15,000 IOPS getting fired at the SQL Server. Let's say that's 5,000 IOPS per disk. Disks can still keep up because they're capable of 5,000 IOPS each. So you're not going to get throttled at the disk level. This is all going to come back just fine. However, the VM is only capable of 12,800 IOPS. So this is going to get throttled. That's all that you're going to get back, right? Now, is this a problem? Maybe, okay? Maybe. It depends on whether your application can absorb this blip in performance. If it's a blip, you might not even notice it. Either you can burst or it will, it'll clear itself up after the app slows down a little bit and there's less I/O. So you might not even notice this. If this is sustained over time, however, you will probably notice this slowdown, okay? So this might be something that you need to take care of by either increasing the size of the VM or turning on the cache. This is assuming, what I have here is assuming that there's no cache. So that's the other thing that we want to talk about is caching. How does caching come into play here? Okay, so you might be asking, how do I know whether I'm being throttled or not? The way you know whether or not you're being throttled is there are a series of metrics that you can look at in Azure Monitor. You can set these up in the Azure portal. You can set up alerts if you want to. You can set up a dashboard that monitors this, but you can't see this from inside the virtual machine because this is all happening in the Azure infrastructure. So there's no performance monitor counter that you can look at from inside the VM that will tell you you're being capped. You might be able to sort of imply that you're being capped by just seeing how much I/O and throughput is being generated in perfmon. Like if you're constantly at that 12,800 IOPS, you can be pretty sure you're probably being throttled, but you won't know for sure. To know for sure, you need to look at these metrics. So the disk capping has two metrics that are relevant: data disk IOPS consumed percentage and data disk bandwidth consumed percentage. So the first one is IOPS, and the second one is throughput, megabytes per second. So this will tell you of the total capacity, what percentage are you at? So if you hit 100% once or twice in a day, you're probably fine. But if you're constantly pegged at 100% of your capacity, then that is potentially a performance problem that you need to resolve. Similarly, you could be capped at the VM level. So the VM counters that are relevant are cached IOPS consumed percentage, cached bandwidth consumed, and then uncached IOPS and uncached bandwidth. So cached IOPS and bandwidth is your local throughput. That's your SSD level provisioning. So you could be throttled at the local level, and then uncached is your remote throughput. So that is what's going directly out to your premium SSDs. Okay, so you could have capping at the VM level. So what do you think? If I have capping at the disk level, what do I do? Change the disk, right? I could make the disk bigger. I could create a new storage pool with more disks in it. I could tune my queries so they do less I/O. I mean, the same things you do on-prem, right? So I either have to size up the disks, or probably the better thing would be to build a new storage pool with more disks, or tune your queries. But pay attention to what the VM level limit is, because you don't want to add so many disks that you add more disks than the VM is capable of. So you need to see how close you are to that limit. So if you don't have room to create more disks in your storage pool, then you may need to up the size of the VM. So if you're having VM level throttling, then you need to up the size of the VM to get more I/O, or change the type of VM that you're using. Because remember, those E-series VMs, especially the V5 VMs, have way more I/O throughput than even the V4 EDS v4 VMs, and also some of the other series have much lower I/O throughput. So if you're not using an E-series VM, if you're using like a D-series VM or something else, you may not be getting as much I/O as you can get in one of these other VMs. So look at either upsizing the VM or choosing a new family. Okay. Oh, do I have time? No, I've got about 10 minutes left, right? Yeah. Oh, 20 minutes. Oh, oh, that's right. I started at 1:20. Okay, great. I could probably do this then. Okay, so let me go to my dashboard, actually. Okay, so here's an example of, this is my dashboard. This is my home page when I hit the portal. So I have I/O throttling metrics for one of my VMs. I've created a graph here that I just keep on my dashboard. And this has the metrics that we were just talking about. So click on that so we get it a little bit bigger. Here you can see there's my uncached bandwidth, uncached IOPS, cached bandwidth, cached IOPS, okay? So that is the metrics that you can look at. And you can see here, I'm barely tickling this VM. I'm not doing a lot of work here. I'm at 3%, less than 1% on the VM level capacity here. So this VM is not working very hard at all. And I'm sorry, I couldn't get attached to my VM where I was doing some HammerDB to have better numbers here. But you can imagine, if this gets close to 100%, that's where you're potentially looking at performance problems. So you can come in here, and by the way, you can add all different kinds of metrics here. There's lots of different metrics that you can look at. So if there's anything else that you're interested in, you can see some of the burst metrics here, if you have a burstable VM. And you can look at reads, writes. You can look at a lot of the kinds of things that you would normally look at in Perfmon. You can see what the VM is getting, and this is all getting taken from the host level. So this is what you can't see from inside Perfmon. So there's a lot of really interesting metrics that you can look at here. And this will help you diagnose, like, not only are you being capped today, but how close are you to the limit? Like, you could maybe set up alerts. And the other thing is, if you do set up an alert, you don't necessarily want a simple alert that just fires anytime you hit 100%. Because on the flip side, I don't want you to panic if you occasionally get capped. It doesn't always mean a performance problem. If it's a blip here and there, it's probably not an issue, right? So you have to come up with some happy medium for how much is a problem. If it's sustained over time, then that's when capping is a problem. Okay. All right, questions? Right, okay, so can you explain the difference between pay-as-you-go, reserved, and the spot? Yeah, so the spot instance is, you want to avoid that for SQL Server. Spot is like, hey, when we have some CPU cycles around, we'll throw them at you. Okay, so a spot instance is kind of like if you have a workload that it's not time dependent, it's not predictable, it can run whenever it can run, then spot instance is like you get our leftovers. So you don't want to do spot for SQL. Reserved is just telling us, hey, I'm going to pay you for 3 years here, so give me a better deal because I'm committing to 3 years of pricing. So you get a better deal if you do the reserved, and there's 1 year and 3 year reserved pricing. And then pay-as-you-go is just pay-as-you-go. You pay, I think the billing is, I even think per second billing. So when you cut it off, it's off. You're not paying for it. So the question is, do they charge you up front for the reserve? I am not exactly sure how the billing works. I don't think they actually charge you up front, but I think if you want to kill the VM before the 3 years is up, I think there's some centralized reservation system that you can use. I honestly will tell you I'm not a billing expert, so I would say dig into some of the billing documentation and pricing documentation. Hopefully you can get some more answers there, because I don't want to tell you things that are not right. Okay. Any other questions? Do we have anything online? Nope. Okay, great. All right, so let's talk more about this host caching that I was just telling you about. So host caching is enabled at the disk level, per disk. So for every premium SSD you attach to the VM, you can set caching separately. Now, the picture that I have on the screen actually comes from the portal when you're provisioning disks. So as I said, so your OS disk for the VM, that's always going to be set to read-write caching. I just leave that as the default. I don't touch that one. Your data disks should be set to read-only, and any disks that host your log files should be set to none. As I was talking about before, because SQL Server, we have to flush the I/O directly to the disk, we don't want to, we can't take advantage of that write caching, so you'd be wasting it turning it on the log drive, okay? Now, if you use a marketplace image to deploy your SQL Server, we configure all of this for you. The marketplace images have a storage configuration wizard. You tell us how many disks you want for your data files and how many disks you want for your log files, and we will automatically configure the caching settings appropriately. So using a marketplace image, you don't have to remember any of this. We do it all for you. So this would be if you were configuring it on your own, you want to make sure these settings are correct. The other thing I should mention here while we're talking about provisioning is that because the tempdb drive, the D drive, is ephemeral, when you put tempdb on there, there's actually a little bit of extra work you have to do, because if the VM fails over to another host and you lose the D drive, you lose everything on it, including the folder structure. So when you come up on the new host, you need to recreate the folder that holds the tempdb files. So you need a startup task for Windows that recreates the folder structure. We also do that for you if you use a marketplace image. So if you choose to put tempdb on the D drive, and it'll do that by default in the deployment experience, we automatically create a job for you that will recreate that folder structure, so you don't have to worry about it at all. If you do it manually without the marketplace image or without the IAAS extension, then you would have to create that job yourself. So that's another benefit of using a marketplace image. We are working on the ability to do it after the fact. So like if you install the IAAS agent extension after deployment, and then you move your tempdb to the D drive, we're working on a way to be able to deploy that even after the fact. But right now, you have to use a marketplace image to get that automatically. Otherwise, you have to configure the job yourself. And there's a blog for that out there if you look at our SQL VM documentation. OK. So how does this host caching work? So you have your VM. If the I/O request is against a drive that's cached, then it automatically goes through the cache first. So all read requests are going to hit the cache first, and then if it's not in the cache, then they'll go out to the disk. So if the read is not in the cache, the read is counted towards both the cached and the uncached limit, okay? Because we're hitting both the cache and the drive itself, that IUP is counted twice, once for the uncached limit and once for the cached limit, okay? If the data is available in the cache, then the read goes out to the cache and it comes right back. We never hit the disk. This read is counted only against the cached limit. So this is where you get those free extra IOPS, because this caching mechanism is all free. You can just turn it on. You can choose not to use it, but then you're leaving I/O on the table, because we'll give this to you for free. So you turn this on, and provided that the read is that it's in the cache, then you never hit that uncached limit. So this is a way for you to preserve that remote throughput for where you really need it, which is generally your transaction log, okay, and for the writes on your data files. So this is one way that you can boost your performance without even making any changes to the VM, any changes to your database or anything. You just turn this read caching on, and you're good to go. Now, a write operation, as I said, we mark all our writes with flush. We have to flush them all the way through to the disk. So a write operation will always hit both the cache and the disk itself, and will hit both limits, the cached and the uncached limits, okay? So a write against your data file will count towards both. But you can see why it's important for your log drive to not have caching enabled, because then you're wasting cached IOPS and you're wasting space in the cache for I/O that will never be able to benefit from it. So it's really, really important to make sure your log drives don't have caching turned on, and also important to separate your data and your log files so that you can set the caching appropriately. I mean, it's always been a best practice on-prem to separate data from logs. It's even more important in Azure because you're actually configuring them differently. And you may even be sizing them differently, you know, because your transaction log is really important for it to be fast. So maybe you do choose an ultra disk for your transaction log, but you don't need that for your data files, so you put premium on the data files. So you really need to think about this maybe a little differently than you think about it on-prem, okay? All right, so let's take a look at the benefits of this host caching all together with our original example. So you remember we had those 15,000 IOPS and they went out to the disk. Disk is totally capable of them, but the VM, it was not. But if I turn on caching, the cached limit is 77,000 IOPS and 485 megabytes of throughput. 77,000 cached IOPS. That's way more than the 12,800 that I was capable of before. So guess what? If at least some of those IOPS come out of the cache, I can do that 15,000 IOPS, no problem. Because some comes from the cache, and then so I get the 12,800 from the remote, and hopefully the rest comes from the cache. Now, your mileage may vary on how much you can use this cache, right? So we don't know how much your workload is going to be able to leverage the cache. So you can't assume that you'll get 100% of your reads from cache, right? So what we do is we did some testing, and on average, we were getting about 30% bump. So we've decided that if you want to estimate the benefit of cache, you can estimate about, let's say you get about 30% of your reads from the cache. Let's assume that. It's pretty conservative. Some will get more, some may get less. But if you want to kind of give yourself an idea of what you'll get, that's what we're sort of estimating, okay? So let's tie all this together. Choose the right disk. Make sure you're using P30s or P40s because those are the ones that are capable of caching. Ultra disk if you need low disk latency, and do leverage that temp drive for your tempdb because that's IOPS that you can keep away from the remote storage, right? You want to use that local storage, the high IOPS and throughput that's on the local disk. And again, that's one of the reasons we love those EDS v4, EDS v5 VMs because they got high local throughput. So you can really take advantage of that between caching and tempdb. Okay. Host caching. So remember, read only for your data files, none for your log files. TempDB, if for some reason you can't leverage TempDB on the ephemeral drive, like maybe the ephemeral drive is too small, you need a really large TempDB, you can always put it on a remote disk, just like your data files, and in that case, you would want read-only caching for your TempDB as well, okay? Now, write acceleration. This is something that I didn't mention before, but the M-series VMs are capable of this write acceleration. This is something, again, you turn it on at the VM level. It's a host level thing. And it's a way to get some extra speed on your I/O. So it lowers the latency. So this is really great for your log files. So you enable it just the way, same way you enable caching. There's a checkbox in the portal. And it really can improve latency. So it's great for your log drives. So if you happen to be using M-series VMs, then this is one of those things you just want to flip it on. There's like not many reasons I can think not to. Okay, so if you're on an M-series, consider write acceleration. And then storage configuration. So remember, we configure this storage for you if you use a marketplace image and you use the SQL Server VM deployment experience. We will build storage pools for you that pool together multiple P30s. You just tell us how many drives you want. We will create the storage pools with the appropriate settings for you. We will turn on read caching. We'll make sure it's off on the log drives. We will do all of this configuration for you. So I do recommend that you leverage the marketplace images and use that deployment experience to deploy your SQL Server VMs. You can also do that through an ARM template, by the way. We have an ARM template that gets you the IAAS extension and the storage configuration as well. So it doesn't necessarily have to be through the UI. You can do it through ARM as well. All right, so choosing the rest. Oh, again, one more time. Any questions before? Okay, great. Going faster than I guess I cut more slides than I thought. Or maybe I thought there'd be more questions. That's okay, good, because we get to talk more about this. I was worried we wouldn't get to this, so this is good. So I told you how the VMs work, but I didn't necessarily tell you how do you match what you have into what I just told you about. This is where things are really, really important. It is really important for you to know what your workload is generating in order for you to know which one of these VM sizes to choose. So you need to monitor your workload and figure out how much IOPS and throughput this thing is generating. It's one thing that many customers don't know, because you know how many CPUs you have in the machine, you know how much memory you have in the machine, but you don't necessarily know how much I/O throughput you're generating unless you look at it through perfmon. So this is one of those things that often gets overlooked, and it is honestly the most critical decision for you to make when you're running SQL Server in Azure, because SQL Server is an I/O-bound application almost always. How many times are you having CPU issues or you're having memory issues? No, you're having I/O issues. Or if you're having memory issues, it's probably because you're having I/O issues, or vice versa, right? So it's critically important for you to understand this about your workload. So monitor it using perfmon, or if you're already using some kind of monitoring tool on-prem, collect some basic performance counters. These are not even SQL Server counters. These are disk counters. Disk reads and disk writes. These are your IOPS. So disk transfers per second are your total IOPS. Disk reads would be your reads. Disk writes would be your writes. And I recommend you measure them separately, because remember, the reads can come from cache, but the writes can't. So you need to understand which limit this I/O is going to come from. So measure reads separately from writes. Measure logs separately from data, separately from tempdb if you can. Reads and writes per second. Disk read bytes, disk write bytes, that's your throughput. So that's your megabytes per second. You know, obviously do the math and turn it into megabytes per second. And then your latency, average disk seconds per read and seconds per write. Now latency, you can't really translate so much latency into Azure, because you're gonna get what you get. You can choose premium or you can choose ultra, and you get whatever latency comes with that. But if you know that you have low latency and you think that your application is sensitive to it, then you might want to make a conscious choice to go with ultra. Now I find, this is one thing I wanted to caveat on latency. I find a lot of customers they put too much importance on latency. I had a customer, they had really low latency. They were super concerned about Azure because it's much higher latency. They did their performance testings. Application didn't even notice it. They were like, it was totally fine. It didn't matter at all. So do your due diligence to actually test the app and see if it matters. Okay, so uncached IOPS and throughput roughly maps to your transaction log reads and writes, plus your data file writes, and let's say if we use that 30% number, then about 70% of the reads on your data files. And then cached IOPS and cached and local IOPS and throughput roughly maps to tempdb reads and writes, because you're going to put the tempdb on the D drive, plus data file reads and writes, because your data file reads and writes are all going to go through the cache if you turn on read caching. Okay, so that's how you can map these perfmon counters to those limits that you see in documentation. Or you can run our SKU recommendation tool. So the data migration assistant, the DMA, has a SKU recommendation tool built into it. It will collect the data for you, it will analyze it, and it will spit out a size recommendation for you based on your workload. So do leverage our tools. That is available in the DMA. It's also available in the new Azure Data Studio inline migration tool. So use that to it's the SKU recommendation tool, and that will help you spit out a VM size based on your numbers. Okay? So wrapping it up, EDS v5, best price performance that's available today. M-series, high memory, high throughput. For smaller workloads or dev tests, the DDS v5 is my favorite VM series. So if you don't want to do the work, just go with this. And then so this is my Sprinkles VM, and then this is the one, when in doubt, pick this one, EDS v5. But even better, when EBDS v5 comes out, the double Sprinkles VM, this will be coming out soon in GA. This will offer, hands down, best price performance for SQL Server on Azure. Highest I/O throughput, 1 to 8 core to memory ratio. This is the Cadillac of VMs for SQL Server. Okay? Double Sprinkles VM. Okay? I do encourage you to look at our best practices documentation. We've got a lot of it out there. We've got a checklist for everything that you need to know when you're running SQL Server in Azure VM. We've got a separate one for sizing, another one for storage. Then we've got my blogs that I've written on price perf in the SQL Server blog, as well as we just released a security best practices and HADR best practices as well. So everything you need is all in our documentation. And if it's not there, file a GitHub issue and we'll get it there. Okay? Great. So don't forget to send me your feedback. Thank you so much for coming today. And if you have any questions, please feel free. I'm happy to take more questions if you have them. But don't forget, fill out your feedback. Yes? Is there any reason you can't put tempdb on the root of the D drive? SQL Server won't let you, because you can't set the ACLs on the root correctly. You need the folder structure. You can't set the security permissions on the root. You have to set them at the folder, for those of you that don't know what an ACL is. OK. Anything else? We're good? Nothing online? OK, great. Thanks very much, guys. Safe travels home and enjoy the rest of the conference.